Hi everybody, welcome for the second day's programming of Code Vita 2020. So what are we going to work? What sort of problem are we going to work today? Pattern printing. Ha, a lot of people have. Would an MNC bother about pattern printing? Why not? Even I used to think like you few years back. And then I found pattern printing is a very interesting part of computing. It will test you. Can you think ad hoc then and there to solve the problem? So that definitely is going to be a challenge. So most of the organization they use pattern printing to check that quality of the candidates. Okay, good. So this is the problem. Pattern printing problem description: decode the logic and print the pattern that corresponds to given input. N equal to 3, you can take a photograph of this if you wish to. Then pattern would be whatever you see on the screen. Okay, for n equal to 4, this is the pattern. And the constraints is n can go from 2 to 100. So it doesn't look too complicated. Let's move on. So this is how the output looks like, right? A trapezium. Or you can also see it as the mirror image of a triangle's mirror image. Either way we can look at it. So let's look at some more detailed information. That would be much better for us. So let's look at it. For n equal to 3, this is what they have given. You may be thinking, no Sridhar, but that was looking more complicated. Relax. Stick on. Okay, then for n is equal to 5, this is what they have given. So here I'm making it look little different. There are two halves which I need to work. Okay, there are two halves which I need to work. Then in the yellow, you would find that I have said 5, 4, 3, 2, 1. Any pattern, you need to look like at a row and column. So how many rows? 5 rows. And how is it traveling? 1 to 5 or 5 to 1? 5 to 1. Then how many columns? In row number 5, 5 columns. For row number 4, 4 columns. For row number 3, 3 columns. Once you determine this, once you are convinced about doing this, then we can start moving. What about the blue box? Cool. 1, 2, 3, 4, 5 is a running number. What about the second green half? That needs little focus. Because you can print this line. You cannot go back and print. When you complete this line, the second half of the green box also have to be shown as an output. Which means I should go 1, 2, 3, 4, 5, 26, 27, 28, 29 and 30. Have a space or a star depending upon whatever they ask you to do it. 6, 7, 8, 9. Try to do 23, 24, 25. So here also 4, here also 4, but the starting number seems to be a little different over here, that is all. Okay, so here it is 26, 22, 19, 17 and 16. Relax, we will be able to find out. Look at it. I think even when I look at this 26 and 22, what is the row number? 4. 26 minus 4 becomes 22. 22 minus 3 becomes 19. 19 minus 2 becomes 17. 17 minus 1 becomes 16. I thought I need to think a lot when I am coding. I think, let's verify once again. Okay, n is 7. Okay, and goes 7 to 1. Okay, 1, 2, 3, 4, 5, 6, 7 and 50. Okay, now 50 minus 6, 44. 44 minus 5, 39. 39 for this yellow, I think I would differentiate this, the different color. I think that would be much better for you. Maybe this. No, let me fill it up with a different color. So changing the font, if I just make this fill with a different color, a lighter one, that's okay. That looks much better. Okay, so 50 I should be able to determine. Minus 6, 44. So that's the 44 is the beginning number for 6. So 44, 45, 46, 47, 48, 49. Focus. But the next 39 is arrived only with 44, which means I might have to use two identifiers. One to hold onto the 44, other to print till 49. Then from that holding on, subtract 5, that becomes 39. Print, hold, subtract 4, 35, print, subtract 3, 32, print, subtract 2, cool. So how do I get 50? I think most of you by this time you would have got 7, and if it is 50, 5, 26, 3 and 10. So it is simple, n into n plus 1. So 3 into 3 plus 1 is 10. 5 into 5 plus 1 is 26. 7 into 7 plus 1 is 50. Cool. Job done. Let's look at the algorithm. Accept n. Okay, 1 to n or n to 1? N to 1. Ask these questions. This I would ask you to take a photograph and keep it. That will be really helpful. Always ask this question because most of the time you should see them as a row and column. Who is controlling the number of rows? N. Why? You would find that there are n rows. Next, who is controlling the columns? The row. Row number 7, 7 column. Row number 6, 6 columns. So we'll complete the first half, get the beginning point for the second half. Actually speaking, honestly speaking, I thought I will do that when I am coding. But that is what is called ad hoc. AD space HOC, ad hoc. Then and there. Don't know how. Eureka. That's how it happens. Spacing are stars because what I'm showing you is a space. I think we saw stars there. We will change it. And there's something which is there, question mark. Something which is that what you see and what I am showing, something is missing. Don't bother. We will get that filled. Shall we do the coding? So I have the skeleton ready. So what are the identifiers? N, row, call. Remember, ad hoc, no pre-plan. Go with the flow. And then we need to have one num. And remember, for the second half, who will help me to start with the second half? I'll call it as second half. We'll have a nice name. Second half init num. Second half init num. Okay, fine. What else? I need to print from that one. Print num. That's fine. Anything else? I need one n, I need one row call, and then I need one num for the first half. For second half init num, that would go on a formula and print num. I think we're done. Okay, we need to have the spaces. So int spaces, and for counting the spaces, one space counter. Cool. I think we are done. So let's I have said accept n, but to check, let's just have n is equal to 5. And then we can take it from the keyboard. Cool. So let's move on and this one additional thing. They had said, sir, could you please have a bigger font? I wouldn't mind, but problem is if I make the font any bigger, I need one more screen because it is going beyond my screen. Okay. Let's just stick on. This is, I think, fairly comfortable. I have to go from n to 1. So my row starts with the value as n and would go row greater than or equal to 1, n to 1, which means row minus. And every fresh row should start with a fresh line. This might be little uncomfortable for most of you. Huh? Printf inside for? I don't think that is going to work, ladies and gentlemen. The parts of the for, most of us have been understanding as initialization, condition, incrementation bar decrementation. But we at FindMind, we have a different idea of that. Okay, I'm not a great fan of Mahendra Singh Dhoni, but definitely we have a different idea of that. How do we look at it? We look at that as initial setup. So rho is equal to n. And soon you will add something more. Rho greater than or equal to 1. That is the condition whether to step in or not. Rho minus minus, comma, printf backslash n. Ensure your row goes 1 down and go to the next line. That is the alteration to my setup. Not only identifiers are my setup, even my screen is my setup. Cool, good. Next, for column. Column goes from n to 1, 1 to n. Doesn't make any difference. Col equal to 1. And who is controlling less than or equal to my row? Col plus plus. Cool. And printf a number, okay, comma num. Every time the number has got to be incremented plus plus. And what should be the first value? 1. So here you can see here in the initial setup, num equal to 1. Cool. Perfect. Should we run this and see? Let's try it out. Okay, remember agile methodology. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Perfect. All is well, except for the spacing, because we have not introduced any space, ladies and gentlemen. So for spaces is equal to, if you remember, let's have a look at the spreadsheet once again. No spaces. 1 space, 2 spaces, 3 spaces, 4, 5, and 6. For every row, the number of space that is required is going high, starting from 0. Cool. So the spaces starts from 0, and every time when I go down to the next row, that becomes 1 more spaces plus plus. So space counter starts with 0. Okay, my space counter should be less than my spaces and increment my space counter plus plus. And what do you print? Print a space. Printf space. Cool. Will that work out? Let us just verify. Remember I told you I am not sitting down in a forest. I cannot avoid all these noise. Good. It works. Fine. Not exactly, but relax. Don't bother. It is going. All is well. All is well. All is well. Now let's go down to the second half. Remember, second half, look at it. Second half is exactly the same. Exactly the same, except for it is not num. It is a different sequencing. It is print num. Remember, I talked about it. Why print num? Because look at this. 50 can be calculated. 50 minus 6 is 44. So every time my starting number is getting altered by subtraction of the row. So here this we know. We said n into n plus 1. Okay. First time I will calculate this. After that, subtract this. Subtract. But for printing, that has to be incremented. So one additional identifier for printing. So what will be the value of printing? Print num would get the value of, look at the name what we have. It's going to be, what's the name we have? Second half init num. Second half init num. Print num is equal to second half init num, and he will go from that. And remember, second half init num gets subtracted by the row every time. So let me put this into the next line so that it will be comfortable for us, comma, this value becomes this value minus the row every time. Every time row gets altered, this also. Is it all? Pakka? I think so. Straight out. Print num not declared. Oh, print. And then here I have caps M. Okay. So, huge. Because I did not calculate the second half init num first. So, this goes over here only once. Look how, that is why the for is a beauty. For is a beauty. Okay. So, let's put it in a different line altogether, everything. Okay. Control V is equal to n into n plus 1. So, it's going to be n caps n into caps n plus 1. So let me keep all the initial condition in the first line. Okay, so initial setup in the first line and this in the second line, and the third line can be like this. So this, though you can see, is easy to understand. All these are initial setup. All these are initial setup done once. This is my condition and these are my alteration to my setup. Okay, cool. Pakka? Works. It works, right? Good. Now hold on. Relax. Okay. Let's check for 7. Does he work? Check for 7. Does he work? Hey, it works. Except for if you have a close look at the output what we have and output what they want. Okay, they have given for 4, so let us keep that. So let us also run our code for 4. That would be much comfortable for the comparison. Run the code for 4. Okay. Then let's compare what we have and what they want. This is what I have. Okay. What do they want? Have a look. Good. What is the difference? Here you can see here. I have 1, 2, 3, 4. Look at 1, 2, 3, 4, 1, 7, 1, 8, 1, 9, 2, 0. What is he having? 1, 0, 2, 0, 3, 0, 4, 0, 1, 7, 0, 1, 8, 0, 1, 9, 0, 20. There is no 0. And here I have 5, 6, 7, 14, 15, 16. He has 5, 0, 6, 0, 7, 0, 8, 0, 7, 0, 14, 0, 15, 0, 16 alone he is not having 0. 8, 0, 9, 0, 12, 0, no. 10, 0, no. Okay, in that case, all I need to do is just add a 0 here before the printing. Instead of a space, just add a 0. That is all. This is the twist. This is exactly what we have been saying. Okay, awesome these guys are. Wow. Okay, exactly what they want. We have it here. Except for that last 0 which they don't want. Okay, now this is, do you know what is the concept here? Can you handle the corner case separately? That's exactly, I'm telling you, these guys are just nothing less than awesome. So all you need to do is, okay, now I know how to handle the last case. How? Don't say less than or equal to row, just say less than row. And when you come out, just print the number without the 0. That is all. That is all. Just print the last number, print it without the 0. That is all. Exactly what they want I have on the screen. Exactly. Let's just verify once again. Perfect. Now comes the question. Because in the problem statement, sometimes they would have specified, guys, I can't show you spaces, hence I am showing you with stars. Okay, they have not mentioned anything. It means they want to have star. Okay, so be it. If they want to have stars, let's print stars. How? Instead of space, just print star star. That's all, because we have two spaces. That is all. Now run it. Precisely what they want. Absolutely with no difference whatsoever. Isn't it? Exactly. Now they want this to be done till 100. Okay, I mean, of course, there is not going to be difficult, but it is not going to be something which is comprehensible. So what we will do is maybe we'll do till 10. Okay, let's look at it. Let's look at it. For 10, it's going to be 1 to 10 and then 11. So the last number is 55 and there's a 0. Starting is 56. 57, 0. 58, no 0. 59, 0. 60, 0. 61, no 0. 62, 0. 63, 0. 64, 0. 65, no 0. Same case here. 10 into 10 plus 1 is 101. So 101 followed by a 0. Right? No. Hold on, hold on, hold on. Let me just place it rightly. 101 followed by a 0. Here. 102 followed by a 0. 103 followed by a 0. And last 109 followed by a 0. For 110, no zeros. That's all. Okay. So this is the first part of today's session. Now, what would I do next? Okay, everybody is going to ask me, sir, could you please put the code on one single screen, please? Enjoy, 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 enjoy. Okay. Do you want to return 0 also? Let's have fair. Let's be fair. Right? The thing is sufficient. Fair. Because you need, hold on. Yeah, I'll take my hands off. This is perfect. Paka. Cool. Good. What would we do next? Okay. Remember I told you, I think I told you people to take a photograph of this so that you can try it on your own. And remember this picture. Cool trapezium. So I think fair. I think we can, you will be able to remember this. What next? Yesterday's code, I was using dynamic memory in some points. So I would patch that up. I would talk a little bit more about dynamic memory. The next session, the third session is going to be about a small problem, very interesting problem. Fine. So that is going to be for today. Let me remind once again, though we have given 2 hours, maybe I would say breadth, we would not fill up the entire 2 hours. Every day it might vary. For example, yesterday it went perfectly 2 hours. Today is going to be around 30 plus 20 plus 20, around say 70, 80 minutes. So it should be around 1 hour and 20 minutes. Fine. Other than this, what you can ask us to do? If you have any specific area, any specific point, okay, if you feel we need to address that, we can help you do. We will do it. On a daily basis, I can spend at least 10-15 minutes working on that. For example, the following session is going to be about when would you choose dynamic memory? What do you mean by an array that has been declared using dynamic memory? Clean? Fine. So, I'm not going to say see you again because I'm going to continue with that. Remember, after that, one small problem and then the day would get over. Do ask questions. Do ask questions. You have anything specific, once again, I'm reminding you, ladies and gentlemen, send a message to my number in WhatsApp. I will definitely address that. Perfect. Good. Let's continue for the next session. Give me 15 seconds gap. You can start counting 1. Welcome you back. This session is just going to be a small patchwork. if you follow the previous solution, we have used certain features. So they maybe some of the viewers might have little trouble about certain features in that. So this is going to help you understand certain basic things. Why did we choose to work with a pointer and so on, right? Okay, good. So we have used both dynamic memory allocation as well as we have also used simple arrays. Why is it that the entire industry is running behind arrays ever? Because that is the fastest way of picking up data from the memory. It's as quick as picking up data from a simple normal identifier like num, okay, or a CTR or a CH or a pi. So the time taken for fetching a normal value would be normally much faster than an array access, much faster than a data structure data access. So of the data structures, which gives you the fastest is array. So that is why you would find that every programmer would like to work with an array. For example, in a language like Python, a list itself is not implemented as an array. So when the programmers find that it is not as quick as C, some people who love Python, they create a module called NumPy or SymPy, which will give you a better speed in terms of data access. So that is why you would find that array is the fastest data arrangement. Why? Because it works on a formula. It works on a formula. So the next point, which is very important, is name of the array gives the base address of the array. Though this is not the forum where we can train all these things, but quickly we would like to have a small recap. Name of the array gives the base address of the array. Why is that so important? Because the formula that is required for array access is base address plus size of single element multiplied by index. So that is going to be the formula. So the name of the array is giving you the base address, and the index is given by us, and the size of single element is obvious, calculatable. How that can be done. And who helps this? The square bracket is the operator who does this particular operation. So this is an operation. What is the operation? So this is an operation for us. This is the operation. Forgive me, straight line. Okay, it's as bad as an amoeba. Okay, good, but I'm improving. You won't know. Okay, so this is the formula, and this has to be implemented somehow, and it has got to be obviously implemented as an operator. Who is the operator? Square bracket is the operator, and that is a binary operator. So when you say binary operator, it needs two operands, operand 1 and operand 2. So when you have, for example, ARR 10, so the ARR, for example, if you have a operation like this, ARR, and you have 10. So here you would find the ARR becomes operand 1 and 10 becomes the operand 2. Or you can also say operand 2, operand. What do you mean by that? The what you have been keeping it inside the index can be kept outside. This is absolutely fine. Absolutely fine. So there isn't anything wrong. So this is how you would find that is being accessed. So when do you use arrays? Simple. If the size is known before the code compilation, that is when you start creating a program, if you know the size, straightforward, no questions, arrays. So what is syntax? The data type, the name, and the size. That is going to be the syntax of the array. So to make it more clear, how would you say? Type, the name, and the size. You would refer using name of 0 to name of size -1. Why name of 0? Here we talk about offset. How far is it from that particular base address? So the first element actually begins at the base address. Hence, when you are there, you don't have to move anyway. That is why you can name of 0. 0 movement. The 1 is 1 element away. So n is n element away. That is why you would find the index starts with 0. So name of 0 to name of size -1. What in case if you do not know the size? What in case if you will know the size only during code execution? How would you handle that? You would find that the recent compilers allows you to have a variable. Wherever I have marked question mark, you can have a variable. And once your program gets executed, once you touch the array, please, I want all of you people to stay focused over here. Once you touch the array, immediately you would find whatever the value of that particular variable. For example, if you would have said something like this, okay, forget my drawing once again, ARR, and if you have said, for example, of n, where you would have said int n, and at later point if you have said n is equal to 20. Now the moment you have the first access of ARR, immediately n's value is being checked and the system immediately handles a dynamic memory allocation on its own. There is a dynamic memory allocation, but this, I want all of you people to say closed. Here at this particular way, you would find the dynamic memory allocation is not done at the heap, it is done at the stack. Please stay focused over here. Int n is equal to 20, and later you are declaring ARR equal to n. So here there is no way memory can be allocated, because n comes down from the value of n is in a variable. It is in the memory. Look at it, how easy it is for you to think. N is an identifier. It is in the memory. And the memory is accessible only during program execution. You don't have to be a scientist. Simple, basic, common sense is sufficient. Look at that, ARRN. Okay, let me just do once again this. For example, I have said int n. Wow, my handwriting is improving. And here you have said n is equal to 20. And later you have said int ARR of n. Let's be absolutely logical. N is a identifier who has been given a value at 20. So at this particular statement in ARRN can happen only when n is existing. When would n exist? N is an identifier. Identifier is a name given to a piece of memory. That can happen only during execution. You don't have to be a scientist. You don't have to be a rocket scientist to understand this. Keep it simple. Hence, you cannot even initialize that, which we have shown in one of our programming. We have just shown. When you try to initialize, you would find that it would clearly give us an error message. So because somebody can say, hey, I can just say int name of n, but this is dynamic memory allocation handled by the system in the stack. So what is the problem? You can't give it back. You cannot give it back until your program gets completed. Is there a better method? I may get stuck with that. I don't want to get married to that ARR. I would like to just be a good friend. Good. Perfect. Then comes a sweetheart. That's the better way of doing it. How? You can just say here int star and the name. Think this still as an array. Don't look at this as a pointer. Think this as an array. This is where people know, oh my god, pointers come down. It is just a array. So how does the declaration goes? Type star some name. Only thing is there is a small task for us. Allocate memory using malloc or cloc. Note down the point, my honor, dear honor. malloc or cloc. When we are doing it, we are taking control of the memory, and we would be able to give back when we do not want it. And look at the way how you access some name of 0, some name of size -1. Straightforward. No change in the syntax whatsoever. Just because I am using a star over here for my declaration does not mean I have to see stars ever. No way, I don't have to do. Now this is where you would find that people have a fear towards pointers. Boot Chandi. doesn't exist at all. Cool? Good. So what is the difference? So here you would find we need to allocate memory. That is the only difference. We need to allocate memory. We need to allocate memory. We shouldn't forget. That is all is required. So let us have a look at visually. Visually, how is that? For example, if you have just set in days in months, because I very well know there are 12 months in the year. I very well know that it is going to be 31, 28, 31, 30, 31, 30, 31, 31, 30, 31, 30, 31. And only if it is a leap year, that my month of 1 becomes 29. There's a February becomes 29. That is all. So it is kind of static. So arrays, because I know the size during compilation time. So what in case if you do not know, how do you specify? Int star ARRPTR. So ARRPTR becomes an identifier and who have been given the value as null. Let's say the size is known during the compilation time, 15. So all we need to do is allocate memory using malloc or calloc. Let's presume I have used calloc and the location is 4801212. Cool. Perfect. So what happens in the memory now? This happens. So you can see here there are one additional box, that is all. That is all. Absolutely. Absolutely. Understand that. Other than that, there is no difference at all. How would you refer ARRPTR of 0 using square bracket operator? And end is ARRPTR 14. So you look only this particular part. You look at this particular part. Anybody who knows the language, they would say, hey, they are using 0 and they are using a square bracket. But why did they name as PTR? I think forgottenly they have done. It should be an array. That is what? It is intuitive. The moment you see a square bracket, everybody in the world is going to say that is going to be an array. So you don't have to have any change in your thought process. Just learn how to do memory allocation using malloc. That is all required. So what is that one sweet little difference? In array, you don't have a space called days in months where to have the address. But here we have one specific identifier called ARRPTR and 4801212. What does this have? This has data about data. This has data about data. This has data about the data. We can call it as metadata. So the information about the data or the data about the data is fundamentally called as metadata. Other than that, ladies and gentlemen, absolutely there is no difference between a normal array and a dynamically allocated array. Array is contiguous memory. That is all. As long as I can give you contiguous memory, we do not have any other condition, ladies and gentlemen. So this is one point we wanted to address, because moment people see, oh my God, people are using dynamic memory allocation. It's cool. Keep it simple. Let's do a very, very quick recap here now. What did we do? Okay. I welcomed you and I talked about these points. What are the points? Array is the fastest data structure. It works on a formula. Name of the array gives the base address of the array. Okay. Fine. In case if you have any clarification, definitely you would find that you can post us. I can give you a much clarification in the name of the array if anybody has. So the formula becomes base address plus size of single element multiplied by index. Square bracket is the operator which does this job of working as a formula. It is a binary operator. So you got two operands, one outside the square bracket and one inside the square bracket. One of them have to be an address, other has to be an integer. One would be an address, other would be an integer. So, and it can be exchanged. The integer can be in and the address can be out, or address can be in and the int can be out. Perfectly alright. Then, when I know the size, Jolly well, specify and get it done. How do you specify? For example, type, name and size, int ARR. Int ARR and be happy. Sorry, be happy. When you do not know, what do? C gives you where you can keep it as a variable. Even you can get the value from the user. Scanf, ampersand, scanf, percentage D, address of N. Even the user can decide what is going to be the size. So for obvious reason, the area for ARRN can be given only after determining N. Who is determining N? The user. So very obvious you would find that the program is getting executed. So you cannot touch it until you have allocated memory for this, where we are depending on somebody else. And memory is allocated in the stack. So you cannot give back ARR. A better method is using a star. Now, what do you mean by that? Say, for example, as if I know the size, I will mention it after the name. When I don't know, I'll say I don't know. Keep it that way, much easier for understanding. Star means I don't know. So it becomes int star sum. Okay, type star sum name. The one step which we need to remember is allocation of memory. There are a couple of other functions: malloc, calloc, realloc, and free. You would have seen us using malloc, calloc, and free. Calloc, maybe definitely we will use one of the following problems. How do you refer? Look at this sum name of 0 to sum name of size minus 1. Just because it is a point that doesn't have a couple of ones. Remember, this allocate memory without fail. Cool? Paka? Example, int days in months of 12, because I very well know across the world in every country it's going to be 12 months. Right? Good. So how do I refer? Days of in months? 0. Why? This index is fundamentally an offset. How much should I move? So days in month 0 means don't move. Stay there. Days in months 1. Move 1 element. Move 5 elements. Move 11 elements. For example, to reach this particular place, you will move 11. How much? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So when you move 11, you will reach that particular place. Cool? Perfect? Good. So what is that in case if it is going to be an unknown? This is how it is going to be. There is one additional identifier, AR or PTR, starts with null. Okay, cool. Next. Then once we know the size during the compilation, for example, in this case, I take this 15, use malloc or calloc and allocate memory. Okay, and we have given 4801212, which means after allocating memory, ensure you know where it has been given for use. That is why this particular box. Then what do? Fine, refer to them the same way. I've used calloc in my example, so I have just ensured that everything becomes 0. How do you refer? Look at how do you refer the same way how you refer an array that has been declared as an array for during compilation time. Both of them are arrays. Absolutely, there is no difference. Absolutely, there is no difference. Right? So the only visual difference between this and this is, you can see this one additional box, and that is called as the metadata. The ARR PTR is metadata. And what is that one additional free thing you have? You can free it when you do not want it. This cannot be freed. This can be freed. This cannot be given back, but this can be given back. So that is additional thing. Or sometimes even when you know the number of elements, but if you do not want it ever, use dynamic memory allocation. Look how flexible the language is.